All right, hello, I'm Chris,
I'm Luke.
and our project focused on developing a classification model that predicts whether a tweet is about a real-world disaster or not.
In today's world, many people take to Twitter with first reactions and videos of the events that go on around them. This might be people reacting to some movie, news article, or in our case, disasters. In my case, I first realized the potential reporting power of Twitter when the Beirut explosion took place in 2020. Before large news agencies could report on the event, normal people and citizens took to Twitter to share images and text about the scary disaster that took place. Our hypothesis is that we can use tweet text information to predict whether a tweet is about a real world disaster and potentially provide a valuable resource for disaster management and response organizations. In order to classify tweets as disastrous or non disastrous, we must have a labeled dataset. Luckily, we were able to find one which has been manually labeled by experts. The data type is document data, which each document being a collection of words which makes up each individual tweet. Additionally, there are keyword and location fields provided. However, the keyword and location fields are largely null and aren't used in our analysis. Another useful aspect of the data is that it is relatively well balanced, which means accuracy would not be a poor metric for evaluating our classification model. Tweet data is quite messy, which is an inherent side effect of the informality of Twitter. It is not unusual to see odd shortenings of words, as Twitter has a character limit on tweets. Also, users can include hashtags, mentions, emojis, and even pictures, which appear as URLs. This means that the pre-processing stage is quite important if we want to create a successful classification model. We've broken the pre-processing step into two stages. The first one being tweet pre-processing, where we will clean the messy tweets by removing things unique to social media posts, like URLs, HTML tags, non-printable characters, and numerical values. Once the tweet pre-processing and cleaning is done, we move on to the text pre-processing, which we've learned more about, such as lemmatization, converting to lowercase, removing repeated characters in words, removing stop words, and removing punctuation.
Feature engineering is an important part of developing machine learning models that process document data. We use feature engineering to extract meaningful information from the raw tweets in order to make better predictions. By extracting and engineering the features, the machine learning model can better identify patterns and correlations, which can be used to make better predictions. In our case, we chose to create some additional features that summarize the properties of the tweet data and is used alongside the raw vectorized text. Specifically, we chose to include the number of sentences, the number of words, the number of characters, number of hashtags, and number of mentions as additional features in our machine learning models. We also included the average length of words. Another interesting feature was derived while reading research on fake news identification, which is really quite similar to the task we're working on, but just in a different domain. Research has found that extensive use of proper nouns is correlated to fake news articles. So we also chose to include the number of proper nouns and non-proper nouns as features. Next, we trained several baseline models with the engineered features and vectorized text using term frequency and verse document frequency. This allowed us to view the performance of multiple algorithms and choose the one that performed best. Our results are shown here, and as you can see, the logistic regression and multinomial naive Bayes were the highest performing models with F1 scores around 70%. However, since our data is relatively balanced, as mentioned earlier by Luke, we've included the accuracy results as well for each of the models. both logistic regression and multinomial naive Bayes performed well on the test sets with an accuracy of around 80%. The random forest and decision tree appear to have overfitting issues, as the train accuracy was near perfect and the testing accuracy was much less. An additional interesting investigation we performed pertained to feature importance. We were able to extract the top indicative features that point to a tweet being about a real disaster and found these to be the results. We see here that it appears our feature engineering step had a positive impact in the predictability. While many trigger words you would expect to be related to disasters also appear to have high feature importance, like fire, kill, and the word disaster itself. Also, interestingly, California appears to be in the important features. This confused us, and we assume it to be due to the fact that a large number of the tweets in our data set are about California wildfires or California forest fires. Hence, California itself became an important feature. These were pulled from the overfitted decision tree or random forest classifier, so feature importance may be a bit inflated in this image, but in general, it appears to align with the logical reasoning of what might point towards a real-world disaster. There are certainly some caveats in our solution that would not hold up in the real-world implementation. First, the hand-labeled data that corresponded to the real disasters were quite obviously related to real-world disasters and didn't leave a whole lot of room for ambiguous meaning. Additionally, the real-world data about disasters are definitely not balanced, and one could assume that the massive majority of tweets on Twitter aren't about disasters at all. Nonetheless, we are happy with the performance of our models and feel that there is viability in a product that monitors Twitter in real time to predict whether live tweets are about real-world disasters and could provide valuable resources for disaster management and response organizations. Thank you.